Hello Algorand, and welcome to the testing of smart contracts in Algorand. We're going to learn the different concepts for executing testing in our smart contracts and make sure that our decentralized applications are working correctly. In Algorand, we have two different types of testing: unit testing and integration testing. Integration testing is like the common interaction with the ledger. You send a transaction and you can check the transaction execution and results in the Explorer all inside of the ledger. As example, if you remember the past video when we made the AlgoKit utils part, you will find that the AlgoKit utils sends some different transactions to the ledger and you can verify those transactions into the LoRa Explorer. So basically what we're doing there is sending real transactions to the ledger. It can be localnet, testnet, mainnet, or whatever. But you will find some real transaction and you can validate those transactions, you can validate those state change in group transaction, but you're sending transaction to the ledger. That's the main difference between those two types of testing. In the unit testing, we're not sending transaction, we're doing off-chain execution. We're using an emulation of the ABN and we are executing methods, actions, and different steps using this emulation of the ABN, but we're not sending real transactions. You won't be able to verify those execution of transaction of method callings or app calls in any Explorer because we're not sending transaction to the ledger itself. We're just using the emulation of the ABN. It makes the testing some faster because you don't have to wait for the response of the network. You're just using the emulation, but you can't verify this real transaction of a real complete behavior because you're using an emulation. It depends on your scenario which ones you want to use, but we recommend that you use both types of testing when you're creating your application. Let's start in detail with the unit testing. Basically, for the unit testing, you have some different objects. The test context is basically the component for the whole emulation of the Algorand virtual machine. And this is the main thing you're going to import when you're working with the unit testing library in Algorand, in AlgoKit. It has some different interfaces. If you want to interact with the smart contract, you will need to use the contract interface. If you want to interact with the emulation of the ledger, with different states of the ledger that you are emulating, you will use the ledger interface. If you want to create transaction, manage transaction, send transaction, you will use the TXN interface. And if you want to generate some random data, you will use the any interface. Why you have random data? Because remember, this is a unit testing. This is only a off-chain scenario. And you can generate some random data so you can start sending these random numbers or data in the emulation of the ABM. But we also have some stub implementation. If you want to fully replicate the mathematical computation of the ABM, you can use a native implementation, the native interface. If you want to see how the ABN will behave under different contexts, under different scenarios, you can use the emulated interface. And if you want to mock any other action or response that is not already implemented here, you can use the mockable interface. As an example, if you have your application A and your application B, and if you want to send some data or you want to call the application B from the application A, when you're using an emulation of the ABN, you don't have access to the application B because you're only using the application A. Maybe the application B is already deployed in the localnet or in the testnet, but you don't have access because you don't have any kind of context. You're only using an emulation that only exists during your runtime of the testing. You can mock what is the result of the application B and use the result inside of your unit testing. That's an example of how you can use the mockable interface, but it depends on your scenario as well. Now, let's see how you can create a testing on unit test. This is basically a pseudocode of how to use the unit test. And we're going to use the personal bank smart contract. The first test is going to be deposit test. We're using the arrange at assert pattern. And the first thing is going to be that you need to instantiate the test context. Remember, test context is the object for accessing the Algorand virtual machine emulation. You need to deploy the personal bank contract. You need to retrieve the deploy application information, and you will generate a random amount to be deposited. After you have the random number, you will create a payment transaction using this random number, and you will put as receiver the application address. Then you will call the deposit method of the smart contract, and you will include the payment transaction you just created as a parameter. Once you send the deposit, once you call the deposit method, you have to verify or assert that the output from the deposit method is the same as the random number generated. If both are the same, the test will pass. That's basically a pseudocode for creating a test for deposit. Of course, this is only pseudocode. We will see in the next video how to implement this in code. The next unit test is going to be withdraw. For the withdraw, it's going to be very similar. You have to instantiate the test context, deploy the personal bank contract, retrieve the employee application information, generate a random number, create a payment transaction from the random number, putting as receiver the application address, and then you call the deposit method, adding the payment transaction, and then you call the withdraw method. And the assert is going to be the verification of that the result of the withdraw method has to be the same of the random number generated. If both are the same, the test will pass. For the integration testing, we'll change some few lines here. Of course, you can see here the pseudocode is shorter, but we'll verify which one is shorter or longer when we implement the code. For the deposit test, in integration test, remember here we have to make real transaction. We're using the real network. We're not using an emulation. So we're going to be creating different objects here. We're not using the test context, as you can see here. We're going to be using real accounts that needs to be funded. That's why the first step is going to be create pre-funded test account. Then with those accounts, we have to deploy the personal bank contract. We need to create a payment transaction of one algo. This is not random number. It has a difference with the other unit testing. Then you will call the method deposit, adding the payment transaction as a parameter. And you need to assert or verify that the result of the deposit method is the same of one algo. That has to be the same so the test can be passed. And for the withdraw, we need to prepare the depositor account. We need to prepare the dispenser account. We need to ensure that the contract has enough balance. And then we need to call the deposit method. We need to call the withdraw method. And we need to pass the transaction parameter or the payment parameter. We need to cover some inner transaction fees for these methods. Because remember, the withdraw method has an inner transaction. Because in the withdraw method, the smart contract will send some algos to the account that is requesting the withdrawal. This is the main difference. Remember, in unit testing, we don't need to deal with inner fees or different kind of fees because everything is completely emulated, so you don't have to worry about it. But in this case, we're using real networks, so we have to deal with the fees, with the time of response, and all of the things that we need to deal when we're working with a real network. And for assert, we need to verify that the withdrawal operation succeed and the value return is the same as we use requested to be withdrawn. So that's it. Now, in the next video, we will learn how to implement this pseudocode in real code. And we'll see some differences on how to use unit testing and how to use integration testing.